Learning Objective 5 in Section 4.2 is to check appropriate conditions for using the t-distribution for inference about a population mean. So first, let's say what those conditions are. There are three of them. We need a random sample or randomized experiment. We need independence, which we get by the sample size being less than or equal to 5% of the population size. And we need either a normal population or n to be at least 30, because that's what ensures that the sampling distribution of the sample mean will be approximately normal. This first example says a random sample of 52 credit card holders were asked how many times per week they used their credit card. The sample used their credit card an average of 6.8 times with a standard deviation of 2.5 times per week. A box plot of the values is shown below. Check the requirements for using the normal model to draw inference for the population mean mu. Okay, so let's go through our three conditions. Do we have a random sample or randomized experiment? Yes, it says a random sample. Do we have independence? Well, we have a sample size of 52 credit card holders. Can we reasonably expect that that is less than 5% of all credit card holders? Yes, we certainly can. And do we have a normal population or a sample size that's at least 30? Well, it doesn't tell us what the shape of the population is, and we actually can look at this box plot and see that it looks like it's a little bit right skewed. There's an outlier on the right side. The right whisker is longer than the left whisker, and the right side of the box is wider than the left side of the box. But that's okay because our sample size is 52, which is large enough for the central limit theorem to hold, which means that the shape of the sampling distribution of the sample mean will be approximately normal. So the conditions are met since the sample is random, 52 credit card holders are less than 5% of all credit card holders, and n equals 52 is greater than 30. The next example says, a simple random sample of 100 people was collected. Each person was asked, if you own a cell phone, what was your cell phone bill last month? Below is a histogram and a box plot showing the results of the survey. You can see from both of these graphs that this looks to be a right skewed distribution. However, our sample size is 100, which is above 30. Let's answer this question. Based on the histogram and the box plot, explain why a large sample size might be desirable to construct a confidence interval for the mean monthly cell phone bill. Choose the correct answer below. The graphs indicate that the sample data are not independent. Dependent samples require large sample sizes to construct valid confidence intervals. While the graphs don't show us independence, that comes from whether the sample size is less than 5% of the population size. A simple random sample of 100 people is less than all people that have cell phones, is less than 5% of all people that have cell phones. B, the graphs indicate that the underlying population is non-normal. It looks like, since our samples should be representative of the population, that the population is probably right skewed. Such populations require large sample sizes to construct valid confidence intervals. That's true. That's why our third requirement is that we either have a normal population or a sample size that is above 30. Let's read through the other answers just to verify that they are incorrect. C says the graphs indicate that the sample size is small relative to the population size. Sample sizes must be large relative to the population size to construct valid confidence intervals. Actually, we want the sample size to be small relative to the population size. That's the independence condition. But that's not what the graphs show. So there's a couple things wrong with that answer C. And D, the graphs indicate that the underlying population is normal. Such populations require large sample sizes to construct valid confidence intervals. Actually, that is not true because the graphs indicate that the population is not normal. And if it had been normal, then we would not need a large sample size. And I have one more example. The shape of the distribution of the time required to get an oil change at a 15-minute oil change facility is skewed to the right. To compute a confidence interval for the mean oil change time, what size sample would be needed? Any sample size can be used. The sample size is small, less than or equal to 30. The sample size is big, greater than or equal to 30. Or the normal model cannot be used if the shape of the distribution is right skewed. Well, our third condition is that we need to have either a normal population or a large sample size. And by large sample size, we mean at least 30. Mark that in red.